Ever wondered how we could catch fatigue before it becomes a danger? Imagine a truck driver's eyes drooping or a pilot's reflexes slowing. These aren't just moments of drowsiness, they're critical safety risks. The challenge: detecting tiredness reliably when sensors are messy, missing, or plain unreliable. Today, we're diving into a groundbreaking approach that turns imperfect data into a life-saving tool. Let's start with the problem. Traditional systems often rely on a single sensor, like an EEG headset tracking brainwaves. But these are bulky, expensive, and hard to use in real-world scenarios. What if we could use any existing sensor, like a smartwatch or a camera, and still get accurate results? That's where this research shines. Here's the clever twist. Instead of waiting for perfect data, the system learns from imperfection. Think of it like solving a puzzle with missing or blurry pieces. This framework doesn't give up. It infers how the pieces might fit, fills in gaps, and keeps going. It combines multiple signals: heart rate, eye movements, body motion, and dynamically aligns them like a detective connecting clues. Researchers tested this in real-world settings, from lab experiments to actual drivers on the road. And here's the magic. Even when sensors failed or data was noisy, the system adapted. If a camera missed a driver's eyes, it used heart rate or head position instead. It's like having a backup plan that evolves in real time. What makes this different? It's not just about combining data, it's about learning from diversity. The system takes insights from high-precision lab sensors and applies them to simpler, everyday tools. It's like teaching a student to solve math problems using both textbook examples and real-life challenges. The result? A fatigue detection system that's not only accurate but practical, no fancy gear required. Now let's shift gears. Imagine training a machine learning model to spot fatigue using brainwave data. Sounds simple, right? But here's the catch. What if that same model has to work for someone completely different? Maybe their brainwaves look nothing like the ones it was trained on. That's where the real challenge begins. Researchers tackled this by building mathematical safety nets. Think of them as rules that keep AI from getting lost when faced with new situations. They asked a key question: what's the worst-case error the model could make when moving from training data to real-world use? And they tied that error to two factors: how different the new data is from the old, called domain shift, and how close the model is to perfection. Here's where it gets neat. They used a concept called HH distance, a way to measure how different two datasets are. If the data is similar, the model stays sharp. But if it's wildly different, the math shows exactly how much the error could spiral. But here's the kicker: these equations aren't just for fatigue detection. They're a blueprint for any AI that needs to adapt, like a self-driving car learning to handle rain or a health monitor adjusting to diverse users. The better the sensors, like our KAVITA system, the stronger the model's bridge between training and real life. So next time you see a smartwatch or a camera, remember, behind the scenes, cutting-edge AI is learning to understand your body's subtle signals. Because when it comes to safety, even imperfect data can be a lifeline. Thanks for watching, stay curious, and let's keep exploring how tech is making the world a smarter, safer place. Ever wonder how AI systems really stay reliable when they hit the real world? Let's break it down, no jargon, just cool science.